Hello everyone, welcome to Scienceholic's 2023 webinar, A Journey into the World of Chemistry. Thank you so much for your interest in today's session for Chemistry Beyond the Lab. I am the co-host for this session, and before we start, let me give a brief introduction of what ScienceHolic is. We are a youth nonprofit that aims to introduce intricate scientific concepts in a manner that is fun and comprehensible to teens. We also provide volunteer and leadership activities to teens all over the world, including those who have English as their second language. Our main mission is to serve as a free resource for students to learn more about various STEM topics. Other than this webinar branch, we also have published seasonal magazines. Our most recent one is published in April, and it's a biology-themed magazine, which is out 7th edition. You can check it out after this webinar. So now, please let me introduce Spurti Soni Rahat. Would you mind introducing yourself to us?
I'm Spurti, founder of the youth organization littlebiobits. I'm passionate about STEM and would like to study that at university. Not sure specific, but yeah. I also like reading, drawing, and baking.
Thank you so much for the introduction. Attendees, just a reminder to put your questions into the chat, and I will try to bring it up when it's appropriate. If not, we will try to cover it at the end of the webinar. So these are some of the topics that we'll go over today.
So the first topic we're going to go over is the chemistry of food. So here I have some of the main components of food that we need for survival. So the first of them being carbohydrates, and that is our primary dietary source of energy. And this is converted into glucose for use as fuel during digestion. And on a cellular level, glucose is further converted into ATP through the process of respiration. And examples of carbohydrates include fibers, sugars, and starches. Next, we have proteins, which are essential for the development, maintenance, and repair of bodily tissues. And proteins contain amino acids. Proteins are further divided into their separate amino acids during digestion through the use of the enzyme pepsin. And it's also broken down into peptide bonds, I think. And then next we have fats and lipids, which are really important for insulation and energy storage. And basically any excess energy so your fat will be broken down when your body needs energy and doesn't have the primary source to get it. And fats and lipids are composed of glycerol and fatty acids. During digestion, these are broken down into glycerol and fatty acids through the use of the enzyme lipase. Another really important substance is vitamins, which are necessary for a number of metabolic activities. So these are either considered fat-soluble or water-soluble. So fat-soluble vitamins include vitamin A, D, E, or K, and water-soluble include B and C. Vitamins help aid in metabolic regulation and immune system support. Okay, so obviously water, which is very important, and it helps facilitate nutrient absorption, waste removal, and digestion, and is also essential for preserving overall hydration and body temperature. Next, we have food additives, which are chemical compounds added to food to enhance flavor, appearance, or preservation. As I said, preservatives, flavors, and colors are a few examples and are heavily monitored in food safety in order to protect consumers. So next we have the Maillard response, which is a chemical interaction between amino acids and reducing carbohydrates. This is normally when meat is being cooked and is accountable for the production of flavor and browning in cooked food. As I said, it provides flavor and scent to a variety of dishes and is normally most prominent when cooking meat. Next, we're going to look at the chemistry of photography. So in film photography, so when taking photos with a Polaroid, the exposure of light-sensitive silver halide crystals on the film surface to light causes a chemical reaction to take place when a picture is taken. The gelatin emulsion coating on the film contains silver halide crystals, which are typically either silver bromide or silver chloride in suspension. So photons interact with the silver halide crystals on the film when light strikes it during exposure. A latent image of the scene being photographed is produced because each photon has enough energy to activate an electron in a silver halide crystal. The latent image is a pattern of exposed silver halide crystals. So what happens is that these silver halide crystals developed electron traps as a result of the irradiation. And silver ions and halide ions produced by photoexcited silver halide crystals are used in these electron traps. The subsequent chemical reaction in film development is built on these trapped electrons. So the exposed film is submerged in a developer solution during film development, and the developer contains a reducing agent, typically that big word, or metal, which reacts with the trapped electrons in the exposed silver halide crystals. So what happens is that these crystals are transformed into metallic silver and halide ions like bromine minus or chlorine minus with negative charge. So in the portions of film where light has impacted and exposed the silver halide crystals, a reduction reaction occurs, which results in the formation of metallic silver particles. So this is why on the actual picture, it is developed by these metallic silver particles because they're darker than the nearby unexposed portions. So typically the silver halide crystals that haven't been exposed are then cleaned to get rid of, and this is used with a fixing solution. So only the developed metallic silver picture remains after the unexposed and undeveloped silver halide has been dissolved and removed by the fixing solution. Here to show the diagram of a reducing agent. So basically oxidation takes place and a substance loses electrons. And next slide, please. Next, we're going on to the chemistry of agriculture. So chemistry is the invention, formulation, and use of fertilizers, which help maximize crop output. So here I just put some applications of chemistry in agriculture production and fertilizers. So first, chemistry is used to analyze soil samples and assess the amount of nutrients present in the soil. So by using soil testing, we can detect nutrient inadequacies, and farmers may custom tailor fertilizer applications to each crop's unique requirements. So one crop doesn't get too much fertilizer when it doesn't need that much. The process of creating fertilizers involves combining different chemical substances that give plants vital nutrients. So to encourage plant growth, chemistry aids in achieving the ideal balance of micronutrients which are known as the essential elements for plant growth, which is NPK, nitrogen, phosphorus, and potassium. So how the fertilizers actually get absorbed into the plant is that they react chemically with the soil nutrients to release nutrients in a form that plants can absorb. So for some fertilizers, they might be water soluble, so they'll dissolve in water in the soil and travel up the plant roots to be absorbed and be used. So chemistry also helps creating something called controlled release fertilizers, which release nutrients gradually over an extended period of time. And this ensures a more consistent supply of nutrients to the crops and lessens nutrient leaching. Is pH modification. So to get the pH at the ideal levels for crops, chemistry is applied. Understanding the chemical interactions that some fertilizers can have on the acidity of the soil is crucial for successful crop production. So creating a balance and not allowing one area to displace one area when trying to improve another area. So chemistry also aids in assessing the effectiveness of fertilizers in providing nutrients to plants. So this involves researching how plants take in, absorb, and assimilate nutrients. Chemistry also aids in understanding how various nutrients interact with one another in the soil and within plants in order to prevent nutrient imbalances and increase agriculture yields. This understanding is very important. So here's some application methods of fertilizers, which include foliar spraying, fertigation, and soil integration. These methods are all developed using chemistry. So by utilizing the chemical principles, farmers can apply sustainable agricultural practices that encourage higher yields of crops while reducing the environmental effect, and also optimize nutrient supply to the crops and make educated decisions on fertilizer practices. Okay, so here I just put a diagram of the Haber process used to make ammonia. So as I was talking about the three elements that are important, essential for plant growth, nitrogen, phosphorus, and potassium. So one compound that is made in fertilizer, made for fertilizer use is ammonia. And this is just the equation at the top. N2 plus 3H2 is then reacts to become 2NH3. And this is a reversible reaction. So what makes ammonia really useful to be used in fertilizers is that it has a high percentage of like the actual element that's needed. So it has a high percentage of the nitrogen in the compound or percentage mass. So that is why it's used a lot in fertilizers. So the Haber process basically is when nitrogen from the air reacts with hydrogen from natural gas. And what happens is that this is done at a not too low of a temperature, because if it's too high, then a lot of ammonia is produced. So to make it more controlled, it's normally done at a lower temperature, and an iron catalyst is used. So it is reacted, and because it's a reversible reaction, some of the ammonia reverts back to nitrogen and hydrogen. So when the gases are cooling, the unreacted gases are recycled. So this obviously helps get more economical as well. And then you get liquid ammonia. The next slide. So next we're going to look at the chemistry of perfumery. So aromatic molecules are unique substances with a rounded form and a certain arrangement of electrons that give them a great smell. So their electrons flow around the ring in a steady and appealing manner, which is the key to the distinctive fragrance. Because of their stability, aromatic compounds have distinctive odors that make them ideal for usage in flavors and perfumes. Aromatic molecules have a significant role in making things smell nice and delightful due to their pleasant scents. So there are complex combinations of aromatic chemicals that are present in plants, and those make up essential oils. Because essential oils contain a wide range of volatile organic molecules, including terpenes, esters, alcohols, and phenols, their chemistry is intriguing. These substances help give essential oils their distinctive aroma and their medicinal benefits. Many extraction techniques are used to create essential oils. The most used technique is steam distillation. I think there's a diagram on the previous slide, which is in which volatile oils are carried from the plant using steam and is finally condensed and made into the liquid form. Another technique is cold pressing, which is typically used for citrus fruits and extracts the oil from the peel. But certain plants, like rose, are too fragile to be processed via cold pressing or steam distillation. So for this, solvent extraction is used. Plant materials essential oil is dissolved using solvents in this process, and the concentrated oil is produced when the solvent is eliminated. Due to their chemistry and techniques of manufacture, essential oils are useful in a number of fields, including aromatherapy, cosmetics, and food flavoring. So now we're going to look at the chemistry behind cleaning. So one of the chemicals utilized in cleaning goods are called surfactants. So they have two traits. I have a diagram on the right. One loves water and the other hates it. A cleaning product with surfactant surrounds and traps grease and debris when used. The water-hating end clings to filth and oil, while the water-loving end adheres to water. This makes it easier to clean because the surfactants can lift and get rid of dirt from surfaces. Water spreads out and covers surfaces more effectively because surfactants lessen the surface tension of liquid. Another thing that I remember related to having two traits, one loves water and the other hates it, is in our cell membrane, where you have phospholipids and one side is attracted to water, so it faces out of the cell, and the other hates it, so it faces in the cell. And the other side, so it's made of two layers, the head, which is attracted to water, faces inside the cell because of the water content, and the tail, which is repelled by water, faces outside the cell. So another chemical which is used for a variety of purposes, including cleaning goods, are called solvents. Typically, there are liquids with the special capacity to dissolve other substances. So the solvent's molecular structure helps them interact with other chemicals and break their bonds, and that's what gives them their chemical properties. To help remove particles of dirt, oil, or discoloration from materials or surfaces, solvents act by encircling and dispersing the particles. Solvents are useful in many industrial operations, including cleaning, degreasing, and many others because of their capacity to dissolve and transport compounds. So, and now about bleaching agents, which are potent chemicals that are used to clean surfaces, whiten fabrics, and remove stains. The chemistry of bleaching chemicals is essentially based on their oxidative characteristics, which include introducing oxygen to break down colored molecules, leading to color loss or fading. The chlorine bleach, which is commonly used in laundry and household cleaning, is one of the most popular bleaching chemicals. Hypochlorous acid and hypochlorite ions are produced when chlorine bleach is applied to water. The double bonds inside the colored molecules are attacked by these reactive species, which operate as potent or oxidizing agents, causing them to disintegrate into smaller, colorless bits. Another bleaching agent that is frequently used in domestic and industrial settings is hydrogen peroxide. The oxygen that is released when hydrogen peroxide interacts with a colored substance further oxidizes the colored molecules, which causes bleaching or fading of the color. Thank you for listening. I hope you enjoyed that presentation on different areas in chemistry.
Thank you so much. Now we have some live Q&As. There's a question in the chat, but it's, will the recordings of each conference be emailed to the participants? It would be great for people who are not able to make it to the conferences they signed up for. You can find it in our website, which I'll post in a bit. In our website, it shows our social medias, which we post all our conferences, all our webinars in our YouTube channel. So you can find it there in a bit. Thank you so much, though. That was a great question. Is there any other questions regarding the webinar? Okay, if not, then this is the end of the webinar. These are all of our social media platforms, and please give us a follow if you're interested. YouTube is where we will publish the recording of the webinar, and you can find it in our website, which I'll post in the chat now. And attendees, if you're interested in working with us, here are some various ways you can do so. There are 6 teams, and I am in the outreach team. You can also submit an article to be published. If you want a low commitment way to help us, you can become an ambassador. Lastly, please join our mailing list for updates on new articles or magazine releases and webinar updates. Here are all of our partners for today's webinar, as well as magazines that are coming out very soon in September. Please note that there are 2 volumes of chemistry-themed magazine this time, so stay tuned for that. So please, let's say a great thank you to Spurti for her time. And we hope to see you all again soon. Thank you. Thank you for attending, everyone.
Bye, thank you.